Hello, my name is Bailey Hadley, and the protein I was assigned was type 1 collagen. The mutation I focused on was the dominant negative substitution of glycine for a larger amino acid on the COL1A gene. This can cause osteogenesis imperfecta or brittle bone disease. Depending on the severity of the substitution, the results or condition can be either extremely minor or extremely lethal. The normal function of type 1 collagen is structural. The protein codes for osteoid fibers that form the structural and mechanical matrix of the bone and cartilage in human and other vertebrates. This is why this protein is normally found in the extracellular matrix or connective tissues of the bone and cartilage. In the mutated protein, type 1 collagen becomes less active as the dominant negative substitution of glycine for a larger amino acid prevents the formation of the helices of collagen. As a result, the production of osteoid is stopped. Let's break this down. Normal type 1 collagen is composed of 2 alpha chains from the COL1A gene and 1 alpha chain from the COL1A2 gene to form a triple helix. In this model, you can see the 3 separate fibers that make up type 1 collagen. Glycine is showcased as red dots. These fibers come together to form the triple helix shown. In mutated type 1 collagen, in one of the chains produced from the COL1A gene, the amino acid glycine is substituted for a larger amino acid. Let's take a closer look. As shown in this model, the amino acids that make up the alpha chains produced from the COL1A gene are proline, hydroxyproline, and glycine. Proline side chain consists of a carboxyl group, which makes this molecule hydrophobic, which means it excludes water, and associate with other hydrophobic side chains. Hydroxyproline, on the other hand, has a hydroxyl functional group in its side chain, which causes it to be hydrophilic and polar. These qualities allow it to attach to water to form hydrogen bonds. Glycine is a simple amino acid with its side chain containing only hydrogen, making it nonpolar and hydrophobic, meaning it repels water. Glycine's simple structure allows the chain to form a tight twist. Glycine is also responsible for the flexibility of the molecule. In this mutated chain, glycine has been substituted for a bulkier amino acid. The larger amino acid side chain is generally more complex than glycine, depending on the molecule, and tends to have a sulfurhydryl functional group, making the molecule polar and hydrophilic, which allows it to attach to water to form hydrogen bonds. This new bulkier amino acid doesn't allow for the tight twist of the chains like glycine. As seen in this model, the large bulky molecule prevents the formation of the triple helix, which hinders the formation of osteoid and makes the bones brittle. Let's put this all together. Type 1 collagen functions as the structural component in the extracellular matrix of the bones and cartilage in humans. It is composed of 3 different chains, 2 from the COL1A gene and 1 from the COL1A2 gene that come together to form a helix. In mutated type 1 collagen, the amino acid glycine in one of the alpha chains produced by the COL1A gene is substituted for a larger amino acid. This substitution prevents the 3 chains to form a helix and therefore limits the production of osteoid. Those are the fibers that form the structural and mechanical matrix of the bone and cartilage. This can lead to osteogenesis imperfecta or brittle bone disease. At modeling this mutation, I was limited to only showing a small portion of the alpha chains that create type 1 collagen. In real life, the chains are much longer and the dominant negative substitution occurs in more than one part of the chain. My model also didn't account for the real-life effects of the mutation. Osteogenesis imperfecta has ranges from minor to extremely severe. I only showed the basic mutation and not the ranges or different amino acids glycine could have been substituted for. Overall, this mutation is quite complex and has several different variations based on the amino acid that was substituted for glycine. I couldn't quite get all the variations through Plato.